Let's see the next topic in general science, that is force in mechanics. So in this chapter, these are the important thing that you should know: the basics of the force, the formula of force, and the various types of force which are existing in the nature. And the very important one is the numerical. Okay, so numerical, you should be very thorough in this chapter. Okay, and in this chapter we are not going to look into Newton's law of motion, which is very relevant to this concept, but this we are taking it in a separate session. Okay, so the first question is on your screen: which of the following is never alone in nature? Okay, so it is basically the force. So force can never be alone in nature. Why it cannot be never alone in nature? Because according to Newton's third law of motion, to every action there is an equal and opposite reaction. Suppose if an object is placed on the table, even it is at rest, but it is the force which is acting reverse on this body. Okay, so even though it is at rest, it is exerting some force in the opposite directions. That's why it is never alone in the nature. So we have seen the definition of the force in our theory class, where we discussed that force is a pull or push which is acting on an object, and whenever there is a pull or push, it is going to change the state of rest, state of motion, direction and shape and size. And force is a vector quantity. Why it is a vector quantity? You know that force is mass into acceleration. Acceleration is a vector quantity, so force will also become vector quantity. And the very important one is the unit. So SI unit of force is Newton, and the CGS unit is dyne. 1 Newton is equal to 10 power 6 dyne. Okay, that you should remember. The other unit of Newton, you can derive it from the formula. Mass is kg, acceleration is meter per second square. So the other unit is kg meter per second square. And force is a quantity which never alone exists in the nature. Okay. In science, pull or push on an object is called what? Just now we have seen it is a definition of force. Force is nothing but a pull or a push on an object. Okay, so option C is the right answer. What will be the force applied on object of mass m moving with acceleration a? So there is an object of mass m, and with some force it is moving with an acceleration a. Okay, so you need to tell what will be the force applied. So it is basically the Newton's second law, which says that F is equal to ma. So it is mass into acceleration is equal to force. So option C, those who have given, they are right. This derivation we are not going to see in today's session. In the Newton's law of motion, we are going to see how it is derived. Okay. And these are the two formulas of force. F is equal to ma. The other one is F is equal to mv minus u by t. V minus u by 2 is nothing. It is your acceleration, change in velocity by change in time. Okay. The next is an object of mass 20 kg is moved with an acceleration of 4 meter per second. Calculate the amount of force applied to it. 80 Newton, 5 Newton, 10 Newton, 25 Newton. So again the same formula, F is equal to ma, m is 20 kg, acceleration is 4 meter per second. So force applied on the object will be 80 Newton. Okay, so option A is the right answer. A force of 20 Newton applied to an object, it accelerates with the acceleration of 2 meter per second. Calculate the mass of an object. Again the same formula, but in this question he is asking about the mass of an object. So force is equal to mass into acceleration. So force, it is 20 Newton, mass you need to calculate, acceleration is 2 meter per second square. So your answer will be 10 kg. Okay, so the 10 kg will be the mass of object for which 20 Newton force, if we apply, it get an acceleration of 2 meter per second square. Okay, again in this question you need to calculate the acceleration. Again the same formula, F is equal to ma. What is the force? 100 Newton. What is the mass? 50 kg. So what will be the acceleration? It is 2 meter per second square. So option A, those who have given, they are right. Okay, option A is the right answer. Let's see the next question. When a continuous force acts on an object of 8 kg mass for 2 seconds, its velocity increases from 4 meter per second to 9 meter per second. What is the magnitude of applied force? Student, you know, again the same formula, F is equal to ma, and here acceleration is not given directly. You need to calculate the acceleration. So acceleration, as you know, it is change in velocity by the time. So velocity change is from 4 meter per second to 9 meter per second. It is 5 meter per second. Time is what? Time is 2 seconds. So 5 by 2 is the acceleration. What about mass? Mass says 8 kg. Acceleration is 5 by 2. Okay, so 2 ones are 2, 2 fours are 8. So 5 fours are 20 Newton will be the force which is going to apply it in this question. Okay, so option C is the right answer. Let's see the next question. A cricket ball of mass 100 gram moving with velocity 30 meter per second is stopped by player in 0.05 second. The average force exerted by the player. Okay, so let's calculate it. So you need to calculate the force. Force is what? Mass into acceleration. Mass into acceleration. What is the mass? 100 gram. So you need to divide it by 1000 to convert into kg. Acceleration is what? Here the thing is that you need to calculate the acceleration. Acceleration is what? It is v minus u. Since it is stopped by the player, the final velocity will become 0 and the initial velocity is 30 meter per second over 0.05 second. Okay, so if you calculate, it is minus 30 by 0.05, so it will become 600. Okay, so 600. So if you solve it, it is minus 600 basically. So question will have minus definitely. So you can see option C is the right answer because it is the quantity that has minus in front of it. So if you calculate, it is minus 60 Newton will be the force exerted by the player. Okay.